Hi, this is Professor Stuckard, and in this video we're going to go over some of the basics about machine learning. So in this video we're going to talk about what's required for a machine to learn. We're going to talk about the depth of the field and how we have these other adjacent disciplines like AI and data science and a few other things as well, and really how broad the whole topic is. And then I also want to talk about the whole process of machine learning. And we're actually going to take a look at an algorithm that we're going to be using this semester. And we're going to see how, hopefully these simple solutions are really kind of a goal when it comes to machine learning. But before we talk about that, let's talk about why. Well, why are we learning machine learning? So back in 2016, the machine learning market was valued at just about $1 billion. Today, 6 years later, it is now valued at over $21 billion and is expected to grow to over $200 billion by the end of this decade. The reason is, almost every single industry, or from the public sector to the private sector and everything in between, is utilizing machine learning to make their processes more efficient and to increase profit. The reason being is that we now have data and computing power that allows us to analyze these large sets of data very quickly and to, make improvements and make suggestions to what would be the optimal path forward. And in fact, you probably cannot find any large company today that does not have a machine learning division where there are computer scientists and mathematicians working on solving these problems faced by the company using machine learning. It is a humongous growth industry for lots of people. Well, that's the why. Well, what is it? So when we talk about machine learning in the most general sense, we want to talk about the difference between humans and machines. So us as humans, we typically learn by experience. We try something and we figure out what works, either by trial and error, or sometimes we go to school, we're just taught, and there's also the cultural aspect as well. And so we're picking up things every day, right? Our eyes, our ears, our nose, our mouth, we have all these inputs. And, by taking these inputs, we turn them into our conscious experience. And that's how we learn as human beings. Well, with machines can only follow instructions that are written by humans. In fact, that makes computer programming sometimes the most frustrating thing in the world, because your computer program is not ever going to do what you want it to do. It's only going to be able to do exactly what you tell it to do. And that's the same as your calculator too. You might know what you want your calculator to do with the order of operations, but it's only going to do exactly what you tell it to do based upon the rules already set out for using that particular technology. What machine learning does is it kind of branches those two topics together. Machine learning is when humans, us, we program the machines to learn from experience or from data. So we program the machine to take in data, and particularly be able to take in more data even after we've written the program, to hopefully learn. Well, what do I mean by learn? Well, when I say learn, what we really talk about with learning in machines is typically being able to find patterns and then make predictions about those patterns. And again, the idea of the machine learning is we'll create this algorithm, we'll put it into motion, and then the algorithm, our process, the machine learning part, will be able to continue to improve and be able to continue to work as we input more data without the need for it needing to be programmed again, without the need for any more human intervention. As we just add more data, the computer gets smarter and smarter at what it's supposed to be doing. So, machine learning and AI are probably two of the closer fields here, where we have this kind of crossover and this kind of adjacency between disciplines. So again, machine learning, we're trying to get machines to learn and make predictions. The difference between machine learning and AI is that AI also includes, so this is in addition to the machine learning, first of all, natural language processing and understanding. We want to be able to talk to it. So again, if you think about Siri or Alexa, We talk to these devices using our natural language. We don't have to be a super computer scientist with a PhD. We can just talk to our devices because they can understand our natural language. The other part that makes it AI is that it has to be able to access information quickly, which is why Siri or Alexa both need to be connected to the internet. They can take the entire data of the internet to hopefully make their decisions, and they need to be able to make those decisions quickly. If you ask Siri a question about what's the best place to eat, and she doesn't get back to you until 20 minutes later, that didn't do you a whole bunch of good, did it? So again, it needs to be quick, not just accessing the data, but also being able to make conclusions about it. And then lastly, it's acting upon those requests. We want to be able to make specific requests to the AI in our natural language. It needs to be able to access the information and make that decision very quickly for us. So again, machine learning is the subset, and then we build on it in terms of AI. So here is kind of a rough sketch of how some of these things are overlapped. So we see machine learning there in the pink, which again is completely encompassed by AI in the purple, which is also overlapping and adjacent to KDD, which is knowledge discovery in databases, or sometimes called data science, which of course also requires data mining at the very center of it. We need data. Data is incredibly important, which means we also need this adjacent skill for databases. And well, if we're doing machine learning and AI, we also need the pattern recognition, which is there in green, which requires us to understand statistics as well. So now we need to know statistics. And then we have this whole newer branch called neurocomputing. And these disciplines are all overlapping each other. And it's, well, the result of this industry growing by leaps and bounds, that there's all these different avenues that people are now exploring and improving machine learning and AI in. We basically have a technology that's still somewhat, I don't want to say it's in its infancy anymore. We're starting to grow out of that, but now we're at a toddler. Now we're at the elementary school level where we have all of the different students telling all these different jobs they want to be, right? You ask a group of kindergartners, what do you want to be when you grow up? You're going to get a bunch of different and wide variety of great answers, and that's kind of where we are now. So there's all these different disciplines. Now, the nice part is that means with all these different disciplines, there's plenty of places to go find work because, again, all these companies are using machine learning, and whatever you want to go into, well, there is hopefully going to be that option available to you. As you look through these, a few things to kind of keep in mind. When you see words like science, like data science, typically we're relying more on the theory, which again, maybe the statistics or the neuroscience, those sorts of things. When we talk about engineering, that's about implementing theory. And then if we talk about art, and that's really where the end goal should be, is that we want to be able to implement these theories in a way that's satisfying, in a way that's kind of pleasing. And, well, to be successful at any of these things, we're going to have to try lots of different things out and find out what suits you. So, again, as you're kind of thinking this through, keep in the back of your mind, think about, well, what do I want to do with this degree? What would be a field that I'm passionate about? Where can I work in the machine learning field? Because, again, almost any company is going to do machine learning. What kind of company would I want to work for? What kind of industry? What kind of, or maybe it's the public sector. What would I like to do? What would I like to be a part of? And try to make that part of your plan as you continue on through the rest of your machine learning, data science type fields. And again, you might change your mind halfway through, but the important part is, again, we have to keep trying. Okay, so let's talk about now the machine learning process. We'll switch gears a little bit. So to create a machine learning process or a machine learning application, the first thing is, well, we need a question that we're trying to solve. So we need to ask a question and we need to figure out, well, how can I possibly, solve it? And that's going to be finding the algorithm. So we need to understand the question, understand what the problem is we want to solve. Then we want to pick an algorithm that's going to help us solve this the best way possible. And that's what a large part of this class is going to be. We're going to look at a bunch of different algorithms throughout the semester. And we're going to talk about the strengths and weaknesses of each one so that hopefully once we ask a question, if we understand it well enough, we can just implement these algorithms ourselves. And again, all these algorithms are mostly going to be written for us. We're just going to use some of the work that other people have done previously by installing packages and these sorts of things so that we can use some of the work and hopefully determine our own results. Well, once we get our results, though, it's not going to be perfect the first time. Even once we pick an algorithm, the next thing we need to do is really tune that algorithm. How can I improve that algorithm so that it works even better? Because again, even though we have these general algorithms that we're going to use, we might want to tune it for our specific purposes, which is a whole separate idea. So I'm going to talk about one example of machine learning, and we're going to go through the process here just kind of briefly and kind of as an overview of where machine learning is used and how they implement one of their algorithms. And so we're going to talk about Spotify. So Spotify, when they're trying to create a channel for you, well, they're trying to use features of songs that they know you already like to predict new songs that you might like. So when you like a song on Spotify, it looks at a bunch of different variables about that song, like the artist, the tempo, the dynamics, the style, and actually a few other variables as well. And then using that data from you, from those multiple songs that you've liked or maybe disliked, it's going to try to find and suggest similar songs with those same characteristics. Now, this is going to be an example of what's called supervised learning because all of our data is going to be labeled. We have all of our variables, we have our songs, everything is labeled, and we know exactly what it is that we're trying to do here. So, to explain how I would solve this problem, how is Spotify going to recommend a song to us, let's simplify the example a little bit more. Let's say that Spotify has given us 10 different songs, and we liked 6 of them, which are in green, and we disliked 4 of them that are in red. So this is the data set that Spotify is using, this very small data set of just 10 songs. And we're also going to simplify it a little bit further, and we're only going to look at 2 of the variables. We're going to look at the song tempo and the song dynamics. And the nice part about 2 variables is when I have 2 variables, I can plot these in kind of a coordinate plane in 2 dimensions using, again, typically my x-axis, y-axis type of idea. So if we look at this, hopefully we can all interpret graphs pretty well, and we can figure out, all right, well, what are the characteristics of the songs that we like? And if we look at all the dots in green, well, they're kind of clustered up there with the faster song tempo and a more intense dynamics. Whereas the songs that are slower or a little bit more peaceful in the dynamics, those are the ones that we disliked. And so we see that there's a pattern to the data. And again, we can see this easily because it's in 2 dimensions. We humans were designed to be able to see these sorts of patterns. If we started adding more variables, it might get a little bit more difficult, right? If I add a 3rd variable, well, now we're in 3 dimensions, x, y, and z. And again, okay, we could still probably kind of visualize where the groups are going to be. And if I add a 4th dimension, well, now we're in 4-dimensional space. So what does it look like in 4 dimensions? Oh, well, we can't visualize that, right? Humans can't visualize 4 dimensions, but luckily the computers can. Now, back to the problem at hand. Which song should Spotify play next? Should it play song A or song B? All right. If you just take a look here, it should be pretty obvious that Spotify should probably play song B. It's much closer to the group of songs that you liked. Song A is much closer to the group of songs that you disliked. So that's kind of obvious, right? We look at this and it's obvious. But how do I get a machine to understand what's obvious to me? How can I program the machine to be able to recognize this? And again, you might say it's kind of obvious. Well, if it's got a fast song tempo and the dynamics are intense, play that song. If the song is slow and the dynamics are relaxing, don't play it. It's obvious. It's right there. I can see the pattern. Well, again, to be able to explain this, to be able to encode this for a computer to learn, let's take a look at maybe a slightly more confusing scenario. What about this song C? This song C looks like it's kind of right in the middle between the songs I liked and the songs I disliked. Should Spotify play this song? Well, how am I going to tell a computer how to recognize whether it should play this or not. Well, what we're going to use is what's known as the k-nearest neighbor algorithm. And it's actually an incredibly simple idea. We draw a circle. We draw a circle around that song, and then we look at all the likes and dislikes that fall within that circle. So when I look at this, I can see, oh, well, there's 2 songs that we liked within this circle and 1 song we disliked, which means that it's probably much more likely that we'll like this song than dislike this song. We should probably play this song. Now again, like I said, this is a small data set and a small amount of variables, but again, hopefully we can see that the elegance in this solution. All I need to do is draw a circle. A circle is a very simple mathematical shape. And, I have my certain radius and, well, we're good. Well, what we do is, again, maybe it plays song C and we, again, keep going over and over again. Well, each time we like and dislike a song, this adds to our data. If Spotify can keep predicting the songs without having to adjust the algorithm just every time you like or dislike a new song, that's the machine learning aspect. Nobody's programmed it to do anything new. It's just taking in new data and improving its recommendations. Now, when we talk about tuning the algorithm, so improving or tuning our algorithm, this is when we would take things and look at this and say, okay, well, is this the right radius? If I make my radius too small, right, if I make a very small circle around C, it's not going to include any of the dots, so that's not very helpful. If I make my radius huge, well, that's going to include all of the dots, and that's not going to be very useful either. So the tuning part of the algorithm is looking at, okay, I'm going to run through some different scenarios and try to figure out what's the optimized radius for this circle. Now, also what's brilliant about mathematics is that, like we said, there's more than just these 2 variables to songs. Spotify is looking at 4 variables or 5 variables. So we're not looking at a circle, right? If we were doing 3 dimensions, it becomes a sphere. In 4 dimensions, it becomes a hypersphere. Well, I can't visualize what a hypersphere looks like because I don't exist in 4 dimensions, or in 4 spatial dimensions at least. So I can't visualize what a hypersphere looks like. That does not matter to the computers. That is the power of doing this work with machine learning, is that it doesn't matter whether or not the computer can visualize a 4-dimensional hypersphere. We can still adjust the radius and it can still do all of the mathematics just as accurately in as many dimensions as we want. So what we really want, and again, this is, I think, a great example of we have a simple solution to a complex problem that can be scaffolded up into as many dimensions as we want. We have an easy way to tune it. And this is really a brilliant, brilliant algorithm. All right. So that's just kind of our first taste and our first example of a machine learning algorithm that we're going to be using this semester. So we go back to that process, asking questions, creating an algorithm, and tuning that algorithm. So the idea is that, well, we're going to get this wrong a lot of times. First of all, when we ask a question, it might not be the right question to ask. And again, if you've done research projects in the past, hopefully this has actually happened to you as well, where you ask a question and it turns out, well, that wasn't really the right focus. And you kind of switch the focus of your research paper as you work. Because our first question that we ask might not be the right question. And we want to try to, again, adjust things because that's going to adjust how we choose the right algorithm. The first choice algorithm might not be the right one. The more algorithms we know, the better hopefully we can choose them, or the more options we have and the more tools we have in our toolbox, well, the better off we'll be. And again, those first 2 parts kind of go hand in hand. If the question wasn't correct, then maybe the algorithm wasn't correct either. We need to work back and forth. And then another huge consideration is the data. Data is an enormous consideration along with the algorithm. First of all, where's the data from? Is it biased in some way? Number 2, is the data complete? How much data are we missing? Are we going to be able to draw meaningful conclusions if a bunch of the data is missing? And then when we optimize, how do I determine whether or not my algorithm is working properly? The optimization part, well, what does that mean as well? And so we'll talk about this again in just a minute or 2. But I want to go over the machine learning process and what we need to be successful no matter what. Number 1, we need to be able to understand that problem we're going to be solving. Number two, we need to understand the data. Think about the data, how it can be represented. Again, in this example, I made a scatter plot out of it. That was a perfect way to represent my two variables, and it helped lead naturally to what the appropriate algorithm is going to be. But that's a third part. We need to have a knowledge of the wide variety of algorithms that are out there. And that is the main goal of this course, to expose you to the algorithms that already exist so that we know where to apply them, so we can do some of the basics. As you finish your degree and you learn more mathematics, you'll be able to encode more concepts of mathematics into your programming, because you're going to also you're going to develop as coders as well. You're going to grow and learn, and hopefully you'll be able to encode this stuff. And hopefully by the end of your degree, you will actually be able to create your own machine learning algorithms. You're going to see a problem, and hopefully you'll be able to be creative and find your own algorithm. You can write your own algorithms to solve these problems. And you really just need to enjoy just enjoy problem solving. Embrace problem solving. Enjoy getting things wrong and trying new things and testing them out and trial and error. That's really the beauty and the joy of doing this machine learning. You have to be able to enjoy that if you want to do well. And of course, along with that, if you get stuck, try something new. If you try nothing and you're all out of ideas, well, this is not going to be the field for you at all. So, along with choosing the algorithms and then choosing how we evaluate those algorithms and optimize them, there's typically 5 different schools of thoughts, or the 5 tribes of machine learning. All right, and again, there's lots of overlap between the disciplines, there's lots of different applications, and we need to use all these different ideas. So the 5 tribes of machine learning are typically the symbolists, connectionists, evolutionaries, Bayesians, and analogizers. Your book talks about each of these 5 tribes briefly. Your work this week, one of your homework assignments, is to research one of these tribes, which is going to be assigned on Blackboard, and do a little bit more research into each of these tribes. Each of these have all had their moment in the sun as someone develops a new algorithm based upon their way of thinking that works much better than the previous methods, or works better in a specific case. And so the symbolists, their origin is really logic and philosophy. They rely on inverse deduction to solve problems. So very much step A, step B, step C. How do these ideas flow in a logical, coherent way? The evolutionaries, they really look to biology to help solve these problems. Mother Nature has been, using trial and error for 1 billion years here on planet Earth to eventually end up with humans. So Mother Nature's tried a whole bunch of things. Let's use what Mother Nature has already done. Let's build upon her work in our algorithms. So that's the evolutionaries. Then you have the connectionists. Again, they're looking at biology as well, but specifically neuroscience. Again, this is the ones that you're going to have giant neural networks that are all improved through backpropagation. Then you have the Bayesians, who are really rooted in statistics. They talk about probabilities and conditional probabilities and how they all relate to each other using Bayes' theorem. And again, we're going to talk about the statistics involved there for their conditional probabilities. And then lastly, the analogizers. So the origin of this tribe is psychology. So this group relies on kernel machines to solve problems. As you research each of these tribes, what you want to be looking for is typically their best choices, or their most popular choices for representation, which is the algorithm they use for learning, their learner algorithm. So that would be like the K nearest neighbor. Number 2, the evaluation process. How do they determine whether their algorithm is successful or not? And then lastly, their optimization. How do they improve that algorithm? How do they tune their algorithm? So for each of those different 5 tribes, they each really have a different idea for those 3 things. Also, like I said, as you do your research, you should include those 3 things: the representation, the evaluation, the optimization, and maybe even a little bit of history about when they were the most popular, when they were the new guys on the block who had some new idea that we could build off of. Now, the ultimate goal for many people is to combine all of these different tribes, all of the technologies, all of the strategies, and come up with just one single master algorithm that can learn anything. that can be used for what's known as general AI. So Siri would be narrow AI because you can ask Siri, well, what's a good restaurant recommendation, and then how do I get to that restaurant? General AI is something that can hopefully think for itself, something that becomes self-aware, like HAL from Space Odyssey 2001, or Skynet from Terminator, or the machines from the Matrix. Okay, so whether or not we do that, well, nobody knows when it's going to happen, and there's debate as to whether we should do it, but people are working on it anyway, and that is the idea of this master algorithm. All right, so let's wrap up this video now. So can you answer these following questions? So first of all, what is the general method for creating a machine learning process, right? How do I go, what's just the very generalized steps? Number two, can you discuss a few other adjacent fields of study? AI, data science, how do they kind of relate to machine learning? How does this whole thing kind of fit together? Number three, what do you need to be successful in these fields, right? What are the most important things to keep in mind when you do machine learning and data science? Obviously, there's the technical aspect of mathematics and programming and a knowledge of algorithms. But what are some of the less tangible ones as well? And then lastly, what are the 5 tribes? Like I said, you've been assigned to one of those 5 tribes that you're going to have to do a little bit more research in, but you need to be knowledgeable in all 5 of those tribes to really be successful so that you can use the right algorithms in the right scenario. All right. So if you need to, again, go back and review any parts of this video. Hopefully this was educational. And as always, take care of yourselves.